I'm so glad to be here to introduce artificial intelligence and machine learning. And now I'm an assistant professor at College of New Jersey in the US. And so for this short lecture, I just like to cover some like basic concepts of artificial intelligence and machine learning. Okay, so let's get started. So now let's take a look at the definition of artificial intelligence. So this definition is provided by Russell and Novick from their very famous textbook of artificial intelligence. It says that artificial intelligence is the automation of activities related to human thinking, decision making, problem solving, and learning. So that obviously is a fairly broad definition. And I would say that AI system would typically demonstrate much more behavior associated with human intelligence. So such as the reasoning, the knowledge representation, perceptions, motion, manipulation, or even some like social intelligence and creativity. So it's a very broad definition. Okay, so now the AI is around us every day in our daily lives. I just give you several examples. So we start with the example of the recommendation engines, like Netflix and Amazon. So for example, Netflix, instead of having to browse through thousands of movie titles, Netflix can present you with a much narrower selections of movie or drama items that you likely to enjoy. So they do that based on your history, based on your browsing history, as well as other customers like you and what they enjoy to watch. And in a similar way, Amazon recommends what you buy next online. And so the capabilities can save the customer time and delivers a much better user experience. And another example is like the virtual assistant in your iPhone, like Siri or the Amazon's Alexa, who can understand human language. And you can also like give them a order, ask them to set up an appointment with your friends or with your boss, so they can understand human language. And other tool like the image recognition tools like TalkWalker. And I think another example I think you must be more familiar with is the Google's reverse image search. So with the Google's image search, it can give you just provide a picture and they can give you similar picture of different size or even the source picture. So you know where is the original source of the picture. So that's why some photographer, they use the Google image search to identify who is using their picture without permit. So they can recognize what is and who is in the picture. And another example like Gmail. Gmail can help user to spot spam emails. And also like in the banking industry, the technique of like a credit card fraud detection has been frequently employed in this industry. Other examples like the vision recognition systems on self-driving cars and much more. So actually, I think you can think of much more AI applications in your life. So especially nowadays. But right now, I just want to cover the basic types of AI. So AI can be classified into two basic types. The first one is called narrow AI. The reason it's called narrow AI is that they can only learn or to be taught on how to do a specific task. So it's not like a human. A human can learn by themselves. But the narrow AI is only can learn or be taught to do a specific task. This is exactly what we just talked in on our last slides. Those are the recommendation systems, those the credit card detection or fraud detection system. Those are all belongs to the category of narrow AI. And there's another type of AI called general AI. So general AI is a much flexible form of intelligence. It actually can learn how to carry out vastly different tasks on its own. It's just like a human being. So actually, this kind of AI doesn't exist in our real life, but we commonly see them in movies. So I believe you all know the movie Terminator, right? So the Skynet, which is general AI in that movie. And also there's another movie in 2018, it's called Upgrade. And there is an AI called Stan, which is an AI implanted in a human body that can teach human to do some tasks. So those are called general AI. And I give you an example of general AI. So let's say I'm a professor and I just need to see the performance of each student. So with the general AI, I can just briefly say, hey, please give me detailed records for each of my students. So an AI can build a spreadsheet by themselves. So instead of providing the programs with a step-by-step instruction, the AI can do all, you just need to give them your request, and the AI can do all the rest. For example, it can automatically design the structure of the table, automatically record the grades of the homework, group project, quizzes, exams, in-class activities, attendance records, and then they're gonna give you a final score of each student overall performance. So they just do them by themselves. Another example is that an AI can reason about a wide variety of topics based on its accumulated experience. So those AI are commonly seen in the movies, like we just discussed. But although they are not here today, but many AI experts predict that 50% chance that the general AI would be developed between 2040 and 2050. And this chance rising to 90% by 2075. So it's not far. And another topic I want to talk about here is why AI is so popular today. What are the drivers that making AI so popular? So I want to start from the hardware, the hardware platform that can allow us to run AI. Nowadays, the hardware is much faster, augmented by the specialized arrays of a processor like the graphics processing unit, GPU. They have become a very important part of modern supercomputing. And there is another example of hardware. It's called cloud computing. I believe you all familiar with that because what used to be run in a specialized lab with access of supercomputers can now be deployed in the cloud, and much more easier and much more efficient. So the second driver is from the perspective of the software. So nowadays we have some new emerging open source technologies such as Python, the language such as R, as well as Hadoop. So if you are not familiar with Hadoop, I just want to give you a brief introduction. So Hadoop can allow speedier development of scaled AI technology so that we can handle large and distributed data sets. So it's very powerful. And as you can see, if you already got my slides, so each of these blue words, they have a hyperlink. If you click on that link, it will show you a video, which give you a brief introduction of cloud computing, Hadoop. So feel free to watch those videos. Okay. And of course, there are other drivers. And one of them is the most recent advances in machine learning. We call them the machine learning algorithms. We have the algorithm deep learning. Another name for it is called deep neural network, which has been used in Google's DeepMind, as well as other fancy and advanced machine learning techniques like random forest and so on. So those advanced machine learning tools can enable the tackling of ever more ambitious problems with larger and larger data sets. And next driver is the Internet of Things. If you are familiar with the Internet of Things devices, which means basically the interconnected security systems like the cars, electronic appliance, speaker systems, vending machines. So even the sensors in your cars, they all connected with each other. So it created the Internet of Things. So those Internet of Things, they are embedded in everyday life, and we can enable them to send and receive data. So those information have the potential to generate a vast amount of data, which can be used with AI.
So for example, we can use the image. So the image facial recognition system can be used, the image that are actually collected by webcam, right? So the image facial recognition system can use to replace the ordinary payment. Or we can have the self-driving cars gathering the data about the surroundings using the building sensors. And of course, big data as well as the chip storage are other drivers for the popularity of AI. So those are the drivers for the AI. In terms of accounting and auditing, why we need to adopt AI? So I just provide several reasons, but you can think of more. So for example, we used to use some like a traditional human approach of accounting and auditing, like sampling in the auditing. So we do not collect the full population of evidence. We just take some, use some sampling technique to take some samples and we do the audit test. This is what we used to do in the past. And also in the accounting world, we had a lot of accounting estimates, such as we estimate the fair value of assets, we estimate the allowance of a bad debt, but those are actually used the traditional human approach. So nowadays it becomes inefficient and ineffective to keep pace with the change and dynamic marketplace. Another reason is we can use AI to automate some tedious and even repetitive manual work. For example, we can use AI to review the contracts, review the receipts and invoices, and even to examine the inventories. So given such a sufficient large sample of how auditors can make decisions under various circumstances, the AI can allow auditors to automate those tasks. So let's just take reviewing receipts or sales invoice as an example. So the AI can check whether the math is accurate and verifies whether the issuer is correct with some details like the value-added tax identification numbers. So when the software has learned how to handle each supplier, the tasks are subsequently handled automatically. And then the AI can allow it to self-learn and improve its errors, so it can allocate more information. And last but not the least, with the help of AI, for the auditors, we can have more and more evidence from a variety of different channels and sources. So on this next page of the slide, I just give you several examples. So as you can see, the data are from the source like a textual data, audio data, video data, or image data. But in the past, those data cannot be used as audited evidence because they are not machine readable. So we have to use a human expert to read those text documents one by one. But nowadays, with the help of AI, we can read like a business contracts, conference calls transcripts, trading publication, those articles, or even the social media posts. So they can be interpreted with the help of AI, and we can extract very useful information, or we call them data attributes from those sources. For example, what is the sentiment? What is the emotion in this document? Or even we can identify the sentiment score, emotion score for each of the topic, for each of the keywords, for each of the concept in the document. And we use a similar way, and we can interpret audio data like the recordings of phone calls, speeches, presentations, interviews, or even the video data like the surveillance video clips, interview recordings, or even the images. So instead of using a human force to manually read those data, a machine with the AI technology can identify what are the human face, can recognize the human face, and what are the objects, or even the quantity or quality of the objects for each of these different source of documents. And those information are machine readable, so we can directly use them as additional audit evidence. And based on the product literature, we already evidence that with the addition of those audit evidence, the audit quality can be significantly improved. So that is why we can use them in audit. So before we just jump into the discussion of machine learning, I just want to clarify several important key items, or we call them concepts. The first one is the AI, like what we just described. So AI, we can consider it the broader goal of autonomous machine intelligence. And AI is a system that can perceive its environment and take optimal actions given its state. So for example, I believe you're all familiar with Google Maps, right? So Google Maps can reduce the commutes by suggesting the fastest routes, given the current situation of traffic, such as the accidents, such as the construction, such as the weather conditions. And the machine learning actually is a subset of AI. So it's a specific way that we can build an AI. A machine learning usually use several machine learning algorithms. We will talk about algorithms in one second. Okay, so they use several algorithms to parse the data, to learn the pattern from the data. Then they will apply the data pattern they learn to make predictions on the future data. So the key task of machine learning is to make prediction on the future data. And the last concept, I just use example of deep learning, but actually we can use other example like a random forest, decision tree, and other like a support vector machines. So those are the name of machine learning algorithms, or we call them machine learning techniques. So those advanced techniques can has already used in our daily life and has achieved state-of-the-art achievement in like a computer vision, speech recognition, and so on. So we can just consider AI as the big umbrella, and the machine learning is one subset of AI, and deep learning and other techniques, they are algorithms of machine learning. So those are the clarification of the relationship of those key concepts. And if we look at the machine learning, just focus on machine learning, I think the first problem I want to raise is what is the difference between machine learning and statistics, or we call them statistical modeling. So you all know what is statistics, right? What is statistical modeling? They just try to identify and formalize the relationship between variables using some math equations. And the machine learning, in contrast, we just directly learn from data without relying on any prior hypothesis. We just let the data tell us the story. We can allow a system to learn the patterns and the trends directly from the data. So I know you still may feel a little bit confused because the definition of machine learning and statistical modeling kind of similar to each other. So here on the next slide, I provide you with a comparison table between the concept of statistical modeling and the machine learning. So let's just start with the hypothesis, okay? So with statistics, we definitely need a predefined hypothesis. So those hypotheses are usually predefined by the researcher. So for example, if our task is try to predict a likelihood of breast cancer for a patient, so the statistics will make a hypothesis about the relationship between the likelihood of breast cancer and the existence of the historical breast disease of the patient. So they have to make this hypothesis in advance. However, in contrast, machine learning is a data-driven approach. So there is no predefined hypothesis with machine learning. So the data scientists just need to input all the data about the patient. So those data could include, of course, the historical disease of the patient, and even the educational level, or even the profession of the patient, as well as like the marriage status, the home address. Some attributes could describe the lifestyle of the patients, or even some like historical diseases of the patient's relatives or family members. So they just input all the data and let the data tell the story. In other words, it just let the machine learn patterns from those input data, try to identify the patterns and use this pattern to make prediction on the future data. So as you can see, there's no hypothesis. We do not know exactly what is the relationship between each of the input variable, input of the data attributes with the outcome of the likelihood of having breast cancer. We even don't know which variable is relevant or not. Okay, so with those hypothesis things, we can tell the objectives. The objective between these two approach is the objective of statistics is try to, since we already have a hypothesis, right? So the objective of the statistics try to test the hypothesis, or we can call it try to prove or disprove the hypothesis between the variables, the relationship between the variables. And the machine learning aims to develop models, not try to test the hypothesis, but try to make the most accurate predictions. Okay, so similar to the objective, the statistical modeling is focused on explaining how each of the independent variables affect our dependent variable. Dependent variable means the variable that we want to predict. In our last example, it means the likelihood of breast cancer of a patient. So we call statistical modeling explanation focused. So they focus on the explanation. However, for the machine learning, all they focus is try to make accurate and repeatable predictions. So we call them prediction focused. Okay. So the timeline between these two approaches also different, because statistics is actually we call them rearward looking, while machine learning is forward looking. So this distinction is associated with the focus of these two approaches, because machine learning focuses on prediction, which is forward looking, and we train machine learning models on past data to make predictions on future data. In contrast, we train statistical models to quantify the relationship between variables, and that relationship only exists in the data that was generated in the past. So of course, we do hope and we do assume those relationships will hold into the future, but the statistical models are used to describe patterns as waver during the period of data collection. However, learning models are used to project the patterns into the future. So that's why it is one is real forward-looking, another is forward-looking. Okay? And from the perspective of data size, statistical modeling can work very well with smaller data sets like hundreds or even like 20 or 30. It would be work perfectly. However, in order to make a machine learning model perform well, we need a much bigger data size. And from the perspective of statistical modeling, even we increase the data size, the explanatory power of the model usually will not improve. However, when we improve data size, machine learning's power, the performance will be improved significantly. And from the data structure, statistics only works on numbers, so we call them structured data. And the machine learning can work on structured data and unstructured data. Unstructured data usually includes the text data, audio data, video data, images. So those are unstructured data. So they can directly use machine learning to work on them. And from the perspective of number of variables, usually we do not want to include many variables in a statistical modeling because in some extreme case, when the number of the variables exceeds the number of the observations, some statistical model will completely fail. However, we can include as many variables, even thousands of variables in a machine learning model, because machine learning model usually have some mechanisms can identify which variable is relevant and which one just add some noise. However, statistical models do not have such kind of mechanism. And what is more important is, in order to use statistical modeling, we must have some very strict like statistical assumptions. For example, if you want to use like a linear regression, and then you must assume the relationship between independent variable and dependent variable, they are linear. And you must assume there's no collinearity problems with independent variables. However, in the real life data won't usually follow these assumptions. So that's why we need a machine learning model, because they do not have any prior assumptions on the relationship of variables. So to sum up, the statistical modeling, they have a much weaker performance in terms of making prediction. And the machine learning model, they can make very relatively accurate predictions. So they have stronger predictive power. However, the state modeling, they focus on explanation. So you can use them to explain some relationship. However, machine learning, we call them black box approach because they do not worry about how we can explain the relationship because their focus is on the prediction. So we spend a lot of time on the analysis and interpretation of this table. So hopefully you can understand the differences between these two approaches. So if we focus on machine learning will work on two basic problems. The first basic problem is called the classification problem. The basic idea is pretty straightforward. So if you try to make predictions on a class or on a categories, so that's in other words, dependent variable, the predictive variable is a label or a category, then we call them a classification problem. So for example, I try to make predictions on whether an email is a spam or not a spam. So this is called a binary classification problem or two-class classification problem because the dependent variable is a class, is a category. Or if you want to make predictions on a student's grade, so the letter grade could be A minus, B plus, B, and so on, right? So they have more than two classes. So in that case, we call them a multi-class classification problem, or we call them, but it still belongs to the classification problem. So a predictive model to solve a classification problem is called a classification model. So that is the first basic problem of machine learning. And the second basic problem of machine learning is regression problem. The differences between this problem with the classification problem is that the dependent variable is not a class. Now the dependent variable is a continuous variable, is a real value, such as an integer. I give you an example. So let's say we want to predict the selling price of a house. So the selling price is a number, is an amount of money. So in that case, our task is a prediction problem. So if we try to establish a predictive model, then we call this model a regression model. So we have two basic problems. So because we have these two basic problems, we can analyze our machine learning algorithms in terms of these two basic problems. But before we do that, let's try to explain what is machine learning algorithms. Because we just introduced that machine learning is a data-driven problem, a data-driven approach, so we can allow AI system to learn the data pattern directly from data, right? But how come the AI, the system, the machine learning approach can learn the data, can establish a model? So that is why we need to understand the concept of algorithm. So algorithms refers to those like basic approach, basic rules that tell machine what to do, that teach machine how to learn from data, how to establish a model. So we call them the engines of machine learning. So they will instruct the machine how to receive and analyze input data to make predictions. And the learning task includes two basic learning tasks. One is try to learn the functions that map the input variables to the output variable. So that is called supervised learning because we know the output. Okay. Another learning is called unsupervised learning because the data do not have labels, which means they do not know which patient has breast cancer, which patient that does not have breast cancer. So we can use the machine learning approach to identify the hidden structure in unlabeled data. So that's called unsupervised learning. But what kind of algorithm works best? There is no standard answer because it depends on the kind of problem you are solving, the computing resources available, as well as the nature of your data. So you have to try each possible approach and choose the one that give you the most accurate prediction, which means they give you the smallest error. So it's based on a brute force approach. We keep trying and we keep evaluating the performance of each model. So speaking of those machine learning algorithms, I just give you several examples. Those are the most popular machine learning algorithms. As we mentioned, the basic problem of machine learning is that we work on either regression problem or classification problem. So here we use this as a way to separate categories of algorithms. We have some machine learning algorithms that work exclusively for regression problems, like a linear regression, and we have other machine learning algorithms that work exclusively for the classification problems, like logistic regression. And if you compare these two columns on this slide, you may find some algorithms, they can work on both regression problems and the classification problems, such as the artificial neural networks, the decision trees, the random forest. So these three algorithms can work on both regression problems and classification problems. So for example, the linear regression, they try to assume all the relationship of the data, they fit in a straight line. Right? And use artificial neural networks, they try to develop hierarchical layers of artificial nodes, try to map the relationship between input variable and dependent variables. So I'm not going to spend a lot of time to talk about each of these algorithms one by one in detail. I just want to give you a brief introduction about the categories of algorithm and make sure you know what does algorithm mean. Okay, so but actually, data scientists, they are developing more and more algorithms. So here I actually prepare an algorithm mind map for you. So you can find for each of those algorithms, they even have some subset of algorithms, but actually in the real life, we have hundreds of, so that there are much more algorithms on this slide. But we don't have to understand each of the hidden, like the underlying theory or the mechanism for each of the algorithms. We just need to know which algorithms fit for your problem. So let's assume if you want to predict a price of a house, then just need to choose the algorithms for the regression problem. Okay, for example, linear regression, stepwise regression, and so on. If you want to work on a problem that is for a classification problem, you just need to choose which algorithms fit for your data. So there's because we are not the data scientist, or we are not in a major of data scientists, we are not in the major of computer science. There is impossible for us to be like an expert in those of the algorithms, but we just need to know how to apply these algorithms and make machine learning useful in business, in our major or in our work. Okay, so I believe that's the end of today's discussion.